Very good afternoon, everyone. Myself, Abhishek Raj Singh. So the time when I submitted this paper, I was associated to IIT Bombay, but now my PhD is over. So now I'm associated with IISc as research associate. So that's why this change of affiliation is there. I'm presenting my research on design-based constraint handling of site layout planning. My co-author is my thesis supervisor, Professor Venkata Santosh Kumar, Delhi. He's here among the audience. And Sagar Jain, he was an alumni of IIT Bombay. To start with this presentation, the flow of this presentation is as follows. Yeah, so I'll briefly discuss about what the problem of layout planning is. Following it, what are the existing approaches in the literature as well as what is being practiced in the field. Along with it, what we have developed is a constraint typology to understand what are the constraints we need to handle in this research. Then there was a conceptualization of design for site layout planning. It's in similar terms what design for safety is. Then following that, we will demonstrate this conceptualization of design for site layout planning with a test case, and then followed up with results and discussion and the conclusion of this research. So to start with the problem of site layout planning, it's about laying out a temporary facility on the construction site. By very nature of temporary facility, they remain on construction site for some time to aid the main construction. And following that, the contractor removes these temporary facilities. And that's the reason why the temporary facility by name comes as temporary. Since these temporary facilities are there for very small duration or during the course of this construction that's happening, the optimum space utilization is targeted. Along with that, this problem of or the site layout planning directly influence the productivity, quality, and the safety of the construction project. The existing research highlights that simulation-based planning is somewhat sophisticated method to handle this problem, along with optimization-based approach. But on construction practice, in existing practice on construction site, people generally resort to heuristics, where they generally employ their experience which they have gained over the past projects. But since heuristics have their own limitation, people also try to employ optimization-based research or simulation-based planning. And once they have these simulation-based planning or the optimization-based research, they have to find very definite objectives to address. The challenge what these objectives and the constraint process is that every constraint of construction site layout planning or the associated with construction cannot be modeled in a single optimization model. So to address that, what we have done is we try to understand what are the constraints that really associates to this problem. So first we have this primary category of temporal and spatial constraints. Following that, we have a subcategory where the temporal constraint directly tells about the time-based constraints that are associated with this site layout planning problem, whereas the spatial constraint deals with the space. Here in this research, we are primarily focusing on the space, and that's where we are primarily focusing on the spatial constraints to be dealt. To deal with these spatial constraints, what we have proposed is like on similar terms, what design for occupational safety and health does is we design very specific elements that relates to safety on a construction site. We are proposing that design for site layout planning can also be integrated, where designers can be promoted in the role of project management. And that's how what we can do is transformation of these mathematical constraints to a design-based constraint. And to demonstrate, we have a test case. So what we have done is we have developed an LOD 300 model of the main facility. So here, if you will see, we have two buildings that needs to be constructed. Following that, this is the site area which needs to be developed, which can be utilized for the positioning of temporary facilities. This whole thing is being discrete, and the discrete positions or the locations are identified where the temporary facilities can go. So to have the constraints related to position and inclusion and exclusion constraint, we have divided this whole construction site into grids. What I mean by positioning constraint is that we all want a temporary facility to be inside the site, not outside the site boundary. So that's what the positioning constraint means. As well as the inclusion and exclusion constraint deals with the positioning of temporary facilities not overlapping the coming up facility or outside the boundary of the site. Following that, other constraint like sizing constraint is dealt by creating a template of these temporary facilities along with the buffer zone. So since we have to take care of the safety around the construction site or the temporary facilities, if these are hazardous, we always can create a buffer zone around these temporary facilities, and following that, this sizing constraint can be dealt. To demonstrate the implementation, what we have done is we have taken a regular area rather than taking the arbitrary shapes. So by creating a regular area with variation of these, what we are presenting here is that by placing these created variation of the temporary facility at each individual point of the intersection of this grid, we have feasible counts of the feasible positions of these temporary facilities. So since I told that this whole construction site layout has been divided into grids, what we have done is we have considered 10 cross 10 grids. So that is like, sorry, 100 cross 100 grids, which creates 10,000 points for you to place this temporary facility. And just by placing these temporary facilities in the design space itself, iteratively using visual programming, we identified position of these specific variants of temporary facility and found out that out of 10,000 points, we just have 5,000, around 6,000 points, which are feasible just for a single variation of this temporary facility. So just what it does. So now since we have just brought every spatial constraint included in the design, so basically we are preloading the design with the constraint of the site layout planning. What it does is that it transforms the traditional form of mathematical formulation of site layout planning. From design space, it changes to the decision space with filtered out solutions to search for, not the whole feasible solution search space you have to look for now. And that's how it will reduce the time which the mathematical algorithms will take to search for the solution. Alongside, while we were doing this experiment, we also identified one more thing that was related to the orientation of these temporary facility, which was already highlighted in the existing research, where the simple orientation change of this facility, serial number 1 to serial number 8, resulted out more number of feasible solutions. So just by rotating this 90 degree, it creates more possibility for you to position the temporary facility on your construction site. It's already there. That's the reason we didn't highlight it in this research, but it reinforced the existing research. To conclude with this research, it creates, like the research what we have presented, it ease out the layout generation. It isn't solution to an inhibitor of the mathematical optimization, as more constraints can be dealt now, as well as design for planning, which is a similar concept to design for safety, can help in reducing the solution search space by promoting the designers in the field of project management. It also highlights the impact of orientation, as well as the search space reduction is now envisaged to result out site layout solutions in a timely manner, so that the construction can happen quickly. Thanks, and any queries, I'm happy to take. Thank you.
Excellent. Thanks, Abhishek.